So let's say that we want to do another example problem that we've got a person here. They have a ball and they want to throw the ball upwards. And we want to find out, first of all, what's the maximum height. And then I want to know how fast is it moving when it hits the ground. Okay, so we got two parts of the problem. So let's do this part first. Let's do this just to find out what's the highest that it goes. So we need to know a few things about the problem first. Okay, so we need to know the initial velocity, and I'm going to say that the initial velocity V naught is 25.5 feet per second. Okay, so we're going to do this in British units. Okay, and let's say that the initial height of the ball is going to be 5.25 feet. Okay, so I want to find out what's the maximum height up here. So we know we can solve that because we know that x equals x naught plus v naught t plus 1/2 a t squared. So all we got to do is find out what's the acceleration. Well, we know the acceleration is downward. If I want to know the height from the ground. So if I want to know the height from the ground, x naught is going to be 5.25 feet. Okay. And then the acceleration is going to be minus g. Because if up is positive, then the acceleration is down, so that's negative. Okay, remember the sign of g plus or minus depends on which way you say is positive. If you say up is positive, then acceleration is minus g. If you say down is positive, acceleration is positive g. Okay, so x is going to be equal to x naught plus v naught t minus 1/2 gt squared. Okay, so all we got to do is find out what's t. Well, we're trying to find the maximum of this function. How do you find the maximum of function? You take the derivative and set it equal to 0. So dx dt, well, that's just velocity. Okay, and so that's going to be v naught minus gt. Okay, so we set that equal to 0. So t equals v naught over g. So that's going to be, when we plug in our numbers that we had before, that's 0.792 seconds. Okay, so now I can plug that in here. So x naught plus v naught t minus 1/2 gt squared. So that's going to be 5.25 feet plus 25.5 feet per second times 0.792 seconds plus 1/2. Okay, this is the important part. This is 1/2 32.2 feet per second squared times 0.792 seconds squared. Okay, now this is important. Do not just write down 9.81 every time you do this, because in this case, the unit is feet. So you need 32.2 feet per second squared. If you always write down 9.81 every time you see g, you're going to get the wrong answer anytime you're using British units. So if the units don't work out, you know the problem's not going to work. Okay, so that's an important point here, and so you need to be aware of that. All right, so the answer here for the maximum value is going to be equal to 15.3 feet. Okay. Now there's actually an alternate way of getting the same x equals x naught plus v naught t minus 1/2 gt squared, but we already figured out that t was equal to v naught over g. So if I plug that into this equation, then we have x naught plus v naught times v naught over g minus 1/2 g v naught over g squared. So x turns out to be x naught plus v naught squared over 2g. If I plug in all my numbers, 15.3 feet, same answer. Well, of course it's the same answer, the same problem, okay? But there's more than one way of solving the problem. And I want you to know there's more than one way of solving the problem. And I get you, I give you the ability to solve it more than one way. I don't make you do it one way only. Okay. So now you throw the ball upwards, comes up here, comes back down to the ground, and I want to know how fast is it moving at that point. Okay. So what do? There's an easy way and a hard way of solving the problem. Okay. Now, the easy way of solving the problem I say that I know that it happens to be 15.3 feet high. Okay. And so that means if it's 15.3 feet high, then it falls 15.3 feet. Remember, it stops at the top. It momentarily stops. The acceleration is not zero at the top. It's still accelerating downwards. Otherwise, it would stay up there forever. But it is actually falling. Okay. The entire time, the acceleration is the same, downwards at 9.81 meter per second squared, or 32.2 feet per second squared. Again, this is feet, so you got to use the 32.2. So if I want to find, so I know it's going to fall here, x equals 1/2 gt squared. So t equals square root of 2x over g. So that's going to be the square root of 2 times 15.3 feet divided by 32.2 feet per second squared. Okay, so t is going to be equal to 0.975 seconds. Okay, so we know that v is going to be v naught time plus gt. At the top, it's not moving, so that's just going to be equal to gt. So 32.2 feet per second squared times 0.975 seconds. So that comes out to be 31.4 feet per second. Now, there's an entirely different way of solving this same problem. So we have the x naught here. We throw it upward to a certain v naught. It goes up and down. We can do this all in one problem, all in one step. So this is x equals x naught plus v naught t plus 1/2 at squared. Okay, so I'm going to say the final height is 0. So that's going to be equal to x naught plus v naught t minus 1/2 gt squared. So in this case, we can plug all this into the quadratic formula. We find that t equals v naught plus or minus v naught squared plus 2x naught g divided by g. If I plug in the numbers here, we end up with a positive time and a negative time. We don't care about the negative time. The positive time is 1.767 seconds, or 1.77 seconds. And so v is going to be v naught minus gt. So that would be the v naught is the initial 25.5 feet per second minus 32.2 feet per second squared times 1.76 seconds, And so V is going to be equal to a negative 31.4 feet per second. Now, this is basically the same answer as before. Now, the last time we had a positive 31.4 feet per second. Now we have a negative. What's the difference? Well, in the previous example, I started at the top and it fell downwards, and the 31.4 feet per second meant 31.4 feet per second moving down. Here, I said up is positive, so negative means 31.4 feet per second going down. So in both cases, it's 31.4 feet per second moving downwards. So this is another example here of a case in which you need to define your direction. Most of you want to go into science or engineering or computer engineering. You need to define terms, define directions, so that it's obvious when you say something what you mean. Okay. It's always a good idea to draw a picture, as I do here. It doesn't have to be a good picture. It does not have to be a good picture, but draw a picture, okay? Label things, label directions, and make it obvious what's going on. You want to solve the problem right, but most people are going to have a job in which you're working for somebody and you're producing results for someone else to read. You want them to read it right. And so you need to define everything ahead of time, so if they read it wrong, it's on them, not on you. So define your terms, define your directions, draw your picture, and that's always going to be a fantastic step in solving every problem and presenting the results.